In this video, we'll be introducing the Heaviside step function and show its applications when it comes to expressing other piecewise functions in terms of the Heaviside function. But what is the Heaviside step function? Well, the Heaviside function, denoted h of x, is the name given to a piecewise function that has the following properties. For x strictly less than 0, we have that our Heaviside function is equal to 0. So x must be strictly less than 0. If x is equal to 0, then our Heaviside function is not equal to 0. And for x greater or equal to 0, then we have that h of x is equal to 1. And so this is how our piecewise function, the Heaviside function, is defined. And so I've drawn out the graph of our Heaviside function. And what we notice is that there's a discontinuity at x equal to 0. In other words, there's a sort of jump at x equal to 0. And what's important to remember is that at x equals 0, our Heaviside function is actually defined. So h of 0 is equal to 1. And therefore, it's important to remember that here 0 is excluded from this line over here, but included within this line. And therefore, to sum up, the Heaviside function is defined for all x, but it's not continuous for all x. It has a discontinuity at x equal to 0. Now, the Heaviside function is an important function in maths, and it is therefore important to know how to express other piecewise functions in terms of the Heaviside function. So I've written down this function over here, which is discontinuous at x equal to 2. And what I want to do is express this function in terms of our Heaviside function. And in order to do that, it's important to note that the Heaviside function, when it comes to converting piecewise functions to Heaviside functions, the Heaviside function acts as a sort of switch off, switch on function. In other words, when x is less than 0, the function is switched off. And when x is greater than 0, the function is switched on. And in our piecewise function over here, we have two parts in our function. We have 5x squared plus 1 for x less than 2, and 10x squared for x greater than 2. And so what we want to do is, for when x is less than 2, we switch off this part of our function. And when x is greater or equal to 2, we switch off this part of the function, and therefore 10x squared will be switched on. And the way we switch off, switch on, is through the Heaviside function. Now, one thing I want to emphasize is that when we express f of x in terms of h of x, what's in the parentheses here must be these two sections of our function, because we need these two parts, because these parts are what define our function. And so we will have 5x squared plus 1 and also 10x squared in our expression over here, because these two parts define f of x. And therefore, when converting f of x into a Heaviside function, we will need these two expressions over here. What I am first going to do to express f of x in terms of h of x is write down the first section, 5x squared plus 1. So f of x is equal to 5x squared plus 1. And then I'm also going to write down the second section of our function, 10x squared. Alright, but clearly f of x is not equal to this expression over here, because when x is less than 2, well, f of x is equal to 5x squared plus 1. And so, in other words, we need to switch off this function over here for x less than 2. And of course, the way we do that is by using our Heaviside function. And therefore, 10x squared will be multiplied by our switch off, switch on function, h of x. But remember that it needs to be for x less than 2. But the problem is that our Heaviside function switches off when x is less than 0, not when x is less than 2. And so what we do over here is that we write down h of x minus 2. But why did we do that? Well, imagine if we take f of 1. Okay, 1 is less than 2, and therefore f of x will be equal to 5x squared plus 1. And therefore, when we take h of 1 minus 2, it will be h of negative 1. And h of negative 1 is less than 0. and therefore this whole part will be switched off, and we will have f of x is equal to 5x squared plus 1. Because remember, we want this part over here to be less than 0 for this whole part to be switched off. And therefore, since we want x less than 2, we want an expression that is less than 0. And therefore, we subtract by minus 2. We subtract by 2, sorry, to get x minus 2 is less than 0. And if x minus 2 is less than 0, then this whole expression will be less than 0. And therefore, this part will be switched off, because that's how we defined our Heaviside function. If we have x less than 0, if we have any expression less than 0 within the argument of our function, then this part will be switched off. Now, the big problem here is that if x is greater or equal to 2, then this part will be switched on, right? And that's not a problem because 10x squared times 1 is 10x squared. And therefore, we will have f of x is equal to 10x squared, except we also have 5x squared plus 1 in our function. Yet we know that if x is greater or equal to 2, f of x is equal to 10x squared, not 10x squared plus 5x squared plus 1. And so we need to cancel out 5x squared plus 1 over here when x is greater or equal to 2. And the way we do that is by subtracting 5x squared plus 1. But only, and I mean only when x is greater or equal to 2. Because if x is less than 2, then we need this section, our 5x squared plus 1. And our condition that x is greater than 2 is perfectly described by our Heaviside function over here, h of x minus 2. And therefore, what we do is we multiply 5x squared plus 1 times h of x minus 2. So this is our final expression for our function f of x. So now let's go over this expression over here. So we have f of x is equal to 5x squared plus 1 plus 10x squared times h of x minus 2. And what we notice here is that when x is less than 2, x minus 2 is less than 0. Okay, and therefore h of something less than 0 is equal to 0, and therefore this part will be switched off, as well as this part over here, because h of x minus 2 for x less than 2 is 0, and therefore this part will be switched off. And therefore we will have, for x less than 2, that f of x is equal to 5x squared plus 1, which is exactly what this expression means. Okay, and when x is greater than 2, well, we will have f of x is equal to 10x squared times 1, and therefore 10x squared. But we also have 5x squared plus 1. However, this cancels out with the negative 5x squared plus 1 when x is greater than 2, because for x greater than 2, h of x minus 2 will be equal to 1, and this cancels out with this. In general, you don't have to go through all these steps. There's actually a simple technique to convert any piecewise function into a Heaviside. But this technique relies on the theory that I've just laid out in this video. And so to quickly convert a piecewise into a Heaviside, what you first need to do, in this case, for example, where we have f of x, what you first do is write down the first part of the function. And then, so for example, 5x squared plus 1. And then you write down the second part of the function multiplied by the Heaviside function. And the argument of our Heaviside will be x minus the discontinuity. Okay, and then you have to subtract the first part of the function multiplied by the Heaviside at the discontinuity. And so let's quickly go over through an example. So we have this function over here, and in order to convert it into a Heaviside, we first express the first part of our function, minus x squared plus 3. And then we add the second part of the function, so minus 2x squared minus 1. But it's multiplied by the Heaviside at the discontinuity, so x minus the discontinuity, which is x equal to 4, so x minus 4. But we also need to subtract the first part of the function, minus x squared plus 3 times the Heaviside at the discontinuity h of x minus 4. And so this is how we quickly convert the piecewise into the Heaviside. But in order to understand this technique, we need to really understand the theory behind it, which I've laid out in the first part of the video.